Hello and welcome again to Build Better Batteries, a series that unpacks the real-world complexities behind battery materials and cell manufacturing projects. In this episode, we'll dive into why deep integration, system framing, and real test work are not just nice to have, they are essential. My name is Tolakwe Arabisala, and I'm the social media manager at Hatch. I'll be your host. And joining me today are experts from our Battery Market Solutions team, Stephen Angel, the senior process engineer, and Ashleigh Warren, the junior practitioner. What's the most significant way that teams underestimate the complexity of battery facilities?
So, battery facilities typically require very precise and controlled manufacturing environments with harsh conditions and rigorous treatment in order to achieve the specifications that are required for battery grade materials. If we underestimate the impact that a small shift in temperature or introduction of a new contamination in the system can have on the process, it can greatly impact the product quality and safety.
So can you maybe elaborate a bit more on why those changes would impact product quality and safety?
For sure. So, if we don't have a really controlled manufacturing environment, that can mean that we're producing off spec products. And with that, downstream batteries might not have a very safe or reliable operation. Maintaining the controlled environment that's established in laboratory facilities and test facilities is a big challenge at an industrial scale for engineers.
Can you tell us how test work and proof of concept can help to de-risk complexity when committing to full-scale execution?
Whether you are designing a new battery material or a battery cell manufacturing line, the team needs to delve into complexity to identify hidden risks, interactions, or gaps. Proof of concept and test work would help with these identifications.
Interesting. Do we need to justify test work and plant designs that are directly duplicated from other parts of the world?
Absolutely. Even though the project will profit from this previous knowledge, aspects like environmental and engineering codes and climate conditions will influence the operation of equipment, will in turn will impact the chemistry and quality of materials. So I would say test work and proof of concept are most likely required in this case. I would also like to mention that test work and proof of concept will support the refinement of assumptions. They will give meaningful information for scaling up a given equipment or process. And as hinted before, they will help the team to identify those hidden unknowns. This is how you would de-risk complexity, by transforming those unknowns into identified risks and into a plan to mitigate them.
What's different about delivering a battery project in comparison to a traditional industrial build?
When we look at the battery fields, the constant evolution and rapid change really sets it apart from more traditional industries and commodities. Between research into new battery chemistries and advancements in material science, like Stephen mentioned, it's really important to design solutions with flexibility for the future kept in mind. Battery projects for our clients often change, requiring a slightly different specification or using a different feed, and that can have great implications and changes to the project.
A good example about it is the layout of the plant, which is constantly changing along the project.
When a change arises, like a change in the layout, the execution model and contract will dictate how agile our clients can be within the scope of their project. So it's a really good discussion to have up front. With the industry continually growing and our clients wanting to be ahead of the field, it's important that our team responds to change effectively so that we can engineer solutions with that flexibility in mind so that we can deliver both fast and technically sound work.
And so, how do you design for complexity without getting paralyzed by it?
A common goal gives the team focused purpose, but it needs to be constrained. For example, plant capacity, budget, expected product. With a clear goal, boundaries, and visual guidance, the complexity can be divided into critical systems or parts, which can be targeted and designed without forgetting that it does not need to be perfect, it needs to work. The identified critical systems and their interfaces will support the discovery of unknowns, will require a design change management strategy. The key here is to know where to simplify and to consolidate those changes in order to avoid adding chaos and cost to the project. This strategy will allow the project to continue without getting paralyzed by unknowns and their associated complexities.
Thank you so much, Stephen and Ashleigh, for sharing those insights. It was a pleasure having you. And that brings us to the end of this episode. Stay tuned for more insights on Build Better Batteries. Until next time.